We are talking about linear relationships. And what that means is a graph that has a straight line means it's linear. If it's wavy, it is not linear. So a linear relationship means when our x value changes by a common difference, our y value also changes by a common difference. They're related. They're related in a straight line. So for this question, we have a number of hours babysitting, and this is our independent variable. It can be anything we want. We can babysit for 1 hour, 3 hours, 20 hours, whatever we want. And then our money earned depends on how many hours we've babysat. When we're finding a linear relationship, the first thing we do is we look at our common difference. So our common difference on our x values, we have a +2, we have a +2, and a +2. So this common difference is the same, +2, +2, +2. So that means we could be linear. We've got to make sure of our y side as well. Does our y side go up by a common difference? Well, let's check. +20, +20, +20. It does. So our x value goes up by a common difference. Our y value goes up by a common difference. So it is linear. Now, to determine the rate of change, the rate of change means for every hour babysitting, how much money are we earning? What's the change in x and the change in y, and how are they related? Well, I'm just going to plot the points on a graph first. So I had 1, 10, 3, 30, 5, 50, and 7, 70. So it's about that. I'm going to draw my line with a ruler. Okay, for the rate of change, we want to find out how much our y value changes every time our x value changes. So if we go back to our notes, the formula rate of change equals change of y over the change of x. The change of y is 20. Change of y is, oops, didn't leave myself enough room. Change of y is 20. Go back here. Change of y over the change of x. My change of x is 2. Change of x equals 2. And we want to find out, or the rate of change is change of y over the change of x. So the rate of change is 20 over 2. For every $20 we earn, we need to work 2 hours of babysitting. We can reduce this fraction, but we must keep it as a fraction. It must be something over something. So I can reduce it to 10 over 1, but I must leave it as a fraction, something over something, because rate of change uses both the y and the x. A way to remember that it is always y over x is the phrase rise over run. This is a phrase like PEMDAS, something that you'll learn and use and use and use for many years to come. Rise over run. And what that means is we take our y, our change in y first. 10, it went up 10. Our change, it went from 0 to 10. We take our change in y, our rise going up first, and then we take our change in our run or our x. We run along the ground. So it is rise over run. Rise over run. Change of y over the change of x. Okay, so for this next few weeks, we're going to really be thinking that it's y over x when we're talking rate of change or slope, which will be coming up soon.